3 times. So our first question or our first vocab term is we have volume. Markel, read that for me, please.
How much space an object or substance takes up.
Thank you. So volume is, again, how much space an object or substance takes up, right? So when we're measuring volume, we're trying to see how much space it takes, okay? Make sure we're also putting that in our notes if we have it. Our next one, Heaven, can you go ahead and read this next one for me, please? What is air pressure? Thank you. So the force exerted against the surface by the weight of the air above the surface, okay? So usually pressure itself is just the force exerted, but air pressure is the force exerted by air above, okay? So again, that is another thing that has helped us guide through this investigation. So please let's make sure we have that down. And then our last vocab term, could I have Kevin, go ahead and read that last term for me, boss.
The measurement of how compact the mass of a substance or object is.
Thank you. So density, right? The measurement of how compact the mass of a substance or object is, okay? So these 3 terms, these have helped guide us through our investigation throughout what we've done throughout this investigation. So this should actually help us, again, when we go to take our CFU for today, all right? So if you haven't put these in your notes, please take about 30 seconds or so to go ahead and throw that in your notes, and we'll be good to go. Jakayla, can you hear me now? Give me a thumbs up if you can hear me. I know I just saw that you said you couldn't hear me before. But yeah, where you at? I can't see you. Is your camera on? Can everybody give me a thumbs up if you guys can hear me? Am I good? Heaven, can you hear me? Zamaya, you can hear me? Marley, we good? Kevin? All right, perfect. Okay, cool. So now that we have gone through our vocab check, we're actually going to go into a few more things before we get into our CFU again, all right? So, quick question. I know we asked this last time. Which area has higher density? And remember, density is defined as how compact the mass in a substance or an object is. Is it A or is it B? This would be real easy. We talked about this last class. My boy Marley is on fire, and I love it in the chat. I love the responses in the chat. Thank you, Darius. Thank you, Heaven. Thank you, Kevin. Marley, why is it? Go ahead, tell me, Marley.
It's A.
Okay, why is it A?
I think it's A because it's in more compact space than B, because B is out in the air.
Yes, Marley. Thank you. So it is absolutely A, right? Because it is more compact. If you can see the space that is in A, it is a much more compact space than that wide open outside, right? Inside the syringe has higher compact density than outside of the syringe, okay? So if A has higher density, which side has higher pressure? Does A inside the syringe have higher pressure or B outside of the syringe have higher pressure? Higher pressure, think about it. And also I want you guys to remember what we talked about last class. We talked about how pressure and density compare to one another, how they interact with one another. I see Marley is going crazy in the chat. Marley is 100% about to get a 1,000 happy phone call home, and I'm gonna let them know that, hey, Marley need to teach at KIP. Miss Trin, you think you can hire Marley? Because he is going crazy right now. Let's see. Thank you, Khalid. All right. Okay. Miss Bailey, go ahead and read your response. Why did you pick the answer you chose? Can you unmute? Okay. How about let's get a new hand. Let me see. Deshaun, tell me why you picked what you picked.
Because it's more compressed in that place.
Okay, so which one did you pick? I don't, because the rest of the class can't see you. Got you. So you picked A, which has higher pressure. Why you say it has higher pressure?
Because it's more compressed.
Exactly, it's compressed, right? So because it's being compressed, there's force being exerted down inside the syringe versus outside of the syringe, there isn't any force being exerted down. Okay? So, quick question. If the air particles in the syringe are being pressed down and we have the clamp that's holding the air pressure, what do you think would happen if we remove that clamp? Right? Like if we remove the clamp and we let the pressure just keep pressing, what do you think would happen, right? If we removed that clamp, where would the air particles go? We took the clamp out. Where do the air particles inside it go? Darius, what you got, bro? What do you think will happen? Get on mute.
I think they're going to spread into different spaces.
Yeah, right. So you think if the air pressure, that's the air particles that are inside the syringe, they're gonna spread out, right? So when we remove the clamp, matter of fact, how about this, Najee? Can you read for me what that says over there? What happens when you remove the clamp?
When we remove the top air pressure decreases, but because air pressure moves from area of high pressure to low to reach
Equilibrium, right? So we know that there's high pressure that's inside of the syringe. That's what we said before, right? And there's low pressure outside of the syringe, which is where space B is. So when we remove the clamp and we keep out pushing on that pressure, that areas of high pressure, they move back to the areas of low pressure, so that way that they reach equilibrium. Okay? Does that make sense? And I'm seeing a lot of people in the chat who are agreeing right now. Yep. So Deshaun said the air will come out. Marley said that the air will come out. Kevin said the air will come out because it'll reach equilibrium. Thank you, Darius, Kalia. Okay, exactly. So we're all doing a great job with that. So everyone understands that areas of high pressure, they move to areas of low pressure, so that way we can reach what we call equilibrium, or where there is no pressure being applied. Right? There's not neither high nor low. Everything is equal. Okay. So, with that being said, now that we understand the basic parts of pressure, air pressure, we're going to talk a little bit about isobars, like how we did last class, okay? So can I have a volunteer read to me what isobars do? Go ahead, Kevin. Marley, I see you. Honestly, Marley, I'm about to get you a contract myself. You about to be my assistant. Go ahead, Kevin.
The isobars connect areas of similar pressure to show us areas that have the same pressure.
Thank you. So we're looking here. We use these isobars to connect areas with the same pressure, right? So if you see here, we have in Oregon and then we have California. The air pressure is the same. They both have air pressure of 10, 12. So you connect the isobar where the air pressure is the same. And all throughout this map, everywhere you see a bar, those places have the same air pressure. So great job with that, Kevin. So can I have, let's see, who haven't I heard from yet today? Rodnika, can you read that next sentence for me, please? What do isobars have?
Okay, so what you want me to read again?
That second sentence where it says isobars are.
Okay, isobars are. Can this thing move? Okay, isobars are smooth lines with few, if any, kinks, and isobars cannot cross each other. There you go.
Thank you so much for that beautiful reading, Rodnika. So, as you can see here, right, we have our isobars. Matter of fact, let me get my pointer finger out. Bang, y'all see the pointer? I figured out how to do that. I love the pointer now. So, as you can see here, right, all these isobars, they have smooth lines, right? Nothing is like kinky or going all over the place. They're either straight down, all the way around, or they just go all over, right? Like they're really smooth lines. and they also cannot cross each other. So that's how we can tell that these all have the same areas of pressure, right? So we have 112 right here, and then there's another one over here, I believe is 112 that's right, or 1012 that's over here. But because they can't cross each other, you have to make separate isobars, okay? And then our last thing that we have is isobars do what? Marcus, read that last sentence for me. Oh man, you can't hear you, man. Might be something wrong with Mike. I appreciate the try though. How about Tim? Big Tim, go ahead and read that last sentence for me, bro. Sorry, oh my bad. The pointer is acting crazy. All right. So this is Florida right here. This is Georgia right here, okay? And you see the arrow is showing the direction and the wind is blowing. So if we're walking from Florida to Georgia, the wind will be blowing in our face because areas pressure goes from areas of high to low. That's where the wind blows, right? So the wind blows out to the low areas. So if we're at 1012 and we're walking down to 1016, the wind will be hitting us in our face. Does that make sense? So I see a lot of us. Jaden said he got it. Deshaun understands. Marley gets it. Perfect. So now let's just take a look at a different one, right? So if we're here, we have, if we know that, so if we know that air pressure moves, or if we know from Florida to Georgia that or from Georgia to Florida, the wind would be hitting us in our face. Where would the wind be going if we were moving from? Let's see. Where would the wind be moving if we were going from Oregon to California? Right? This has the same air pressure. Where would the wind be moving here? This is a trick question. So if we're moving from 1012 to 1012, where would the wind be moving? We know air pressure moves from areas of high to low. So what happens if the air pressure is the same? Okay, thank you, Kennedy. Jalea, perfect, Jalea. I can't trick Jalea because she's the science teacher herself. Jalea, go ahead and tell me.
Equilibrium?
Exactly, it'll be equilibrium, so there won't be any wind at all, right? There's no air pressure to push the wind anywhere, so it'll be a smooth walk. There won't be no wind in your face. You'll be walking in to be perfectly fine. Now, if we're walking from California to Nevada, now you might get some wind pressure in your face because that's going from 1012 to 1016, okay? And there's higher pressure there. So if you're walking in areas of higher pressure, that's when the wind is going to be in your face, okay? So now that everybody is cool with that, it's now time for us to get to that investigation too. All right, we're going to do that CFU. So at this point, I need